Yeah, good morning, everyone. So, in the last videos, we have seen how to work with single linked list. Now, in today's session, we need to talk about double linked list. So, what is mean by this double linked list? How this double linked list is going to work, we will see. Sir, to demonstrate single linked list, we have taken the individual methods and we have created this Jupyter notebook in that we implemented. But for double linked list, I want to go with the normal approach, like how we are doing our Python program. So like that, we want to take a single file I am trying to create. In that single file, I will perform all these operations. Let us see how we can able to work with that. Sir, I am taking a simple Python program. Okay, I'm taking a single Python program. In this, I will execute all the operations. Okay, please look into this. What is the first operation? Creation of one second. Right. So we will create a separate class to represent double linked list. In the previous example, we have not created any class. So just we created only node class. From that node class only, we performed all the operations. But here, I want to create a separate class for double linked list. Sir, we know very well double linked list in the sense what? So it is nothing but a special list where we are having how many pointers? 2 pointers will be there. So in the middle, we are going to hold data, and in the left pointer, we are going to store previous link, and in the right pointer, we are going to store next node. Okay, like this we are going to represent. So this is nothing but what? Double linked list what we have. I want to represent this. For that, I am taking a class. The name of the class is a DLL, double linked list. Okay. Sir, in this double linked list class, I want to define a constructor. Listen carefully. I am defining a constructor. Inside this constructor, so I have some three special methods are there. The first method is nothing but head. First method is nothing but head. Initially, my head is equal to none. And I am taking another pointer like a tail. Initially, that tail pointer is also none. And I am going to take one more pointer called count. So how many elements are there in the linked list? I am going to count it as a 0. Means what? When you want to create a linked list, we have 3 pointers are there. What is the first pointer? My head pointer is pointing to, so none. And even my tail pointer is also pointing to none. And the count value what I have here is 0, because initially we don't have any linked list. Then this is nothing but the case. Then, sir, how this node is represented? How this node is represented? So inside the double linked list, I am taking a class called node. So whenever you are creating object for node, a constructor will execute. So for this node, I am giving 3 fields. One is a data field. Another one is nothing but a next field. Suppose if you have not given next field, then default value is none. And we are giving previous field. If you are not giving, then previous field will become none. So self dot data is equal to data. Self dot next will become the next node. So self dot previous will become previous node. So this is nothing but what we have. A node class is there and one constructor I defined, which is used to perform initialization activities. Okay. So I defined a class called a double linked list and I am creating an init function. Sir, how to create object for this? Very simple. List is equal to DLL. Have you observed? I created one double linked list. I created one double linked list. Sir, can I print this list? Yes, you have to write a function to perform print operation. Now, this entire list name is nothing but initially list. In this list, one head will be there, one tail will be there, and one count will be there. If you want to create a node for every node, so like this data field will be there, next field will be there, previous field will be there. This is nothing but the class structure what we have. I think you people understood, sir, how to implement by using object oriented principles. Now we have to add the methods one by one. Please confirm, do you have any doubts up to this?
Sir, why you have taken nested class? We can just repeat it class mode different class.
No, sir. If you take in the different class, so what will happen? Outside, any other class also can able to access this node, right? So my requirement is node class should be used only within double linked list class.
Okay.
We want to create any nodes outside of this line. We will create the nodes only inside double linked list. If you want to add first, we will write a function in the DLL class. So from the outside, you will send only data. With that data, this DLL class is going to create a new node. So the node class I am going to use only in DLL class. Outside, I am not using. Got it?
One more thing, as single linked list, initially my pointers are none, but when you have taken next and previous. So while creating a node, we need to give next and previous as well.
Oh yeah. See, even in the previous case also, you can remove this. So because see, what is the default values?
None.
That only will be assigned. But I'm trying to inject a new concept, sir. Actually, we need to prepare like this.
Oh, okay, sir. Yes.
For example, I want to create a first head. So then what we are going to do? Head is equal to a node with data 10. And this for this head, previous field is none, next field is none. Like this, we will create, right?
Yes.
Suppose consider this is node 1. Now I am creating node 2. So node 1 is there with the content 10. Now I want to create node 2. What I am going to do at the time of creating node 2, I will create the data with the 20. Okay. So what is the next field to this? None. What is the
None.
previous to this? N. So then a link will be established like this. So for that purpose, I have given, sir.
Oh, yes, sir.
Right. I request everyone to please confirm. Is the concepts are clear up to this, whatever I covered? Please respond.
Sir, this class node address is also storing in list, sir.
Ah, yes.
The entire three nodes address is storing in list.
Why address concept will come into the picture? We won't use any address. See, this is nothing but a node class, which is defined inside a double linked list. That means a node structure we are defining. And whenever we are creating a new double linked list, this is nothing but the initialization activities which we are going to do. That's all. Only two classes I defined. One is a double linked list class, another one is node class. Got it?
Yes, sir. Tail means, sir.
Tail means last node, sir. In the linked list, suppose if you have some 4 nodes are there, the first node reference is head. Already we discussed, right? The last node reference is nothing but a tail. In the single linked list also we can take like this, but just at the very beginning, if I am telling like this, you people are going to get confused. That's why we have not used a tail there. But a tail represent always last node. Here 2 pointers are there. One is pointing at the beginning, another one is pointing at the ending. Clear?
Yes, sir. Yes, sir.
Right. Sir, let us go for adding the functions one by one. So inside this double linked list,
Sir, your voice is breaking, I think.
Sir, is my voice is breaking? Please confirm, everyone.
No, sir. Clear, sir.
Clear.
Yeah, please cross check. Everyone, please confirm. Is it clear? My voice is breaking. Right. Sir, please cross check from your end. So now we need to define some functions in this double linked list. What is the first function that I am going to use here is, sir, what is the first function that I am going to use here is def. I want to get size of the linked list. Sir, for every function you have to put the first parameter as a self. The reason for that is, since we are working with classes, object oriented principles, compulsory the method which you are defining is always instance method. By using the list object we have to call this. That's why I am putting self as the first parameter. Sir, what about this size? Size is nothing but the number of elements present in the linked list, right? Can I return self.count? Yes. If you create a linked list object and if you call, okay, if you call, so list dot size, what output we are going to get? Initially, we don't have any elements, right? That's why it is going to return the size of the list as a 0. Similarly, sir, I'm going to take def. I'm going to take a function called isEmpty. So this function is going to return true if your list is empty. How you can able to check whether it is empty or not? If your self.count is equal to 0, so there is no more elements, right? So now I think here isEmpty function is going to return true or not? Yes, because my list is empty initially. We are getting true. This is nothing but the first two function, how to check isEmpty and how to check size. So this is nothing but creation of double linked list class, creation of node class, size of double linked list, and isEmpty are. So these basic operations I covered. Up to this, do you have any doubts?
No, sir.
Right.
So
Any
def size return self dot count means
it returns count value. So initially, if there is no list, then count value is 0. So
yes.
whenever we are adding a node into the linked list, we are going to increment this count by 1 unit. In such cases, it will return count value. So whenever we are adding a new element into the list, we will increase count by 1 unit. Whenever we are deleting the elements, we will decrease count by 1 unit. That count will maintain. So how many nodes we have in the list, okay?
Yes, sir. Yes.
Right. Now I want to develop a function called print list, which is going to take self. And I already told, if a self dot head, whenever you are accessing head, so directly we have to take self dot head. If a self dot head is equal to none, sir, can I say my list is empty? Yes. Then immediately return the control. Sir, if your list is not empty, I am taking a current node which is assigned with not head self dot head. Then what we are doing? Until your current node is not equal to none, we are trying to print so current node data, and then I'm going to transfer the control to next node. Current node is equal to, so current node dot next. Like this, it is going to transfer. So at last, we are going to print none. Then we will return the control. See how it is going to work. It is same like previous algorithm, sir. Suppose consider I have a node is there with content 1. I have another node is there with content 2. Double linked list. So 2 pointers will be there. So I have another node with content 3. Next node to the 2 is 3. Previous node to the 3 is nothing but 2. Like this we have. So next node for this node is nothing but none. And the previous node for this is nothing but none. Like this we have. And this pointer name is what, sir? Head pointer. Now I want to print the list. It will check, is your head is equal to none? No, right? Then current node will become self.head. This will become your current node. Can you please check, is the current node is not equal to none? Yes, it is not equal to none. Can you please print current node data? It will print output as a 1. Then current node will become current node tends to next. Now this will become your current node. Then what will happen? Again, while loop is going to be verified. Since it is not equal to none, it is going to return that data also. Then current node will become current node tends to next. It is also not equal to none. It will print its data and current node will become none. Then immediately it will stop. At last we are going to print none. So means what? 1, next field is 2, next field is 3, next field is none. This is nothing but what we have. I think you people understood how print list is going to work. You may have a doubt. Sir, we are using only next field. Why we are not using previous field? See, very simple, sir. The assignment of links will be happened at the time of node creation, at the time of node deletion. For the rest of the operations, links are already there. Just we have to use. That's all. Okay. So this is nothing but what we have. Any doubts up to this, please confirm.
Yes.
Is the print list function, is it clear for you people?
Yes, sir.
Right. So next, of course, if I execute this particular function, like I'm calling list dot, can you please print list? Then what output we are going to get? I think here the list is not yet available, right? So we will get list is empty. Sir, now we have to add the elements one by one. The first operation which I am going to cover here is insert at first. I want to insert at the first location. Sir, I am taking the function like insert at first, which is going to take self comma data. Sir, how to insert at first? It's a very simple operation. First, I am going to create a new node. Okay, how to create self dot node? Because already we have class is there. So self dot node with what arguments we have to pass here. So data field and the next field is none, previous field is none. Like this I am creating. So initially, what is the value of head, sir? The initial value of head is none, right? And what is the initial value of tail, sir? So the initial value of tail is also none. So now I am trying to create a new node. So this is nothing but a new node what we have. Since it is a double linked list, so we have two links are there. Where previous field is none, next field is also none. Okay. What is the name of this one, sir? This is nothing but new node. NN I am taking in the shortcut. Sir, I created a node. Then what we have to do after creation of new node, we have to add self dot count is equal to self dot count plus 1, because one new node we created, right? That's why I am incrementing the count value by 1 unit so that it will maintain how many nodes are there in the list. So next we are going to insert this. We are going to fix the position. If self dot head is equal to none, then what is the meaning? We don't have any elements in the double linked list, right? In such cases, your self dot head will become new node and your self dot tail will become new node, and then we are going to return the control. So this is my first list. Then what will happen? Sir, your head will become this node and your tail also will become this node. Like this I have taken. Now 3 pointers are pointing to the same node, sir. So this is the first case. Let me execute up to this. So here I am going to take, here I am adding list dot insert first of 10 I am taking. Now see what will happen. Sir, is the node is inserted? Yes, 1 is inserted. So is empty is going to return false and we have only one node. Sir, what is this none? Sir, this one print list, sir. So in the print list, after printing the data, just I am giving end is equal to like this. Now see what will happen. 10 next field is none. We have only one node is there. Now I want to create one more node. Sir, where we have to create, since we are calling insert first function, so here it will be created, right? So consider this data is something like 5. So what is the name of this node? Newly created node, right? That's why it will become new node. It is not a new node now. Now see what will happen, how we are establishing. That means if this condition fails, that means if it is not first node, then I am taking self dot head dot previous is equal to new node. Sir, self dot head. So what is the head node here, which is pointing to 10, right? So its previous field I am assigning to the new node. So 10 previous field is assigned to the new node. Next, what we are doing? So your new node is there, right? Its next field will become so self dot head. Sir, where is your new node? This one, right? Its next field is pointing to the head. Sir, now what we have to do? So your self dot head will become your new node or not? That's all. Then return the control. Now this node is pointing to head. That's all. Now this head will be removed. Like this we have. Sir, if you are clear with this, I will try to explain by creating one more node. Can you please confirm is the concept is clear up to this whatever I covered?
Yes, sir. Clear.
Now assume I want to add one more node, sir. Assume I want to add one more node. Sir, where that node is going to be added? So here it will be created. So consider the data is nothing but something like 3. So this node name is nothing but what? New node. By default, it is not a new node. Sir, now we are going to check. Is self.head is equal to none? No, self.head is pointing to some node. Then count value will become 1 unit. Previously it was 2, now it will become 3. And self.head dot previous. Previously it is none. Now we are assigning this one as a new node. And your new node next will become self.head. Now self.head will become new node. Now this will become your new node, but not this one. And since it is a local variables, if you come out from this function, new node also will be, this new node reference also will be gone. This is nothing but what we have. I think insert at function is very clear for you. Let me execute this code. First I insert first by passing 10. Now I am giving 5. Now I am giving 3. Sir, if you print the size, we are going to get 3. And if you print the list, can I expect like this 3? So next field is 5. So next field is 10. And the next field is nothing but none. Let me cross check whether we are getting the same output or not. Yes. This is the way how to insert the element at the very beginning. Please confirm is the concept is clear for you people. Yes, I request everyone to please confirm. Is it clear?
Yes, sir. Clear, sir.
So why are
Sir, your voice is breaking, sir. Pankaj.
Sir, how tail is updated?
When you are inserting at the first, tail won't be updated because tail is always pointing at the last, right? We are inserting the nodes in the beginning. That means end node will be fixed, right? But when you insert at the last, tail node is going to change.
Yes.
Right. So this is nothing but a linked list what I have. Sir, you have implemented a print list function to print in forward direction. Sir, can I print in the reverse direction? Yes, because same function we can implement. So what this function is going to do? It will print the nodes. So from left to right. Sir, I want to write a function which should print the nodes from right to left. Sir, can I write a function for that? Yes. Sir, how to write a function for that? I want to print the data from right to left. How to do that? So print list. Okay. So RL I am taking right to left. So if self dot tail is equal to none, can I say list is empty? Yes. So current node will become which one? Self dot tail, last node. If current node is not equal to none, then print current node data and end will become, sir, like this I am giving. like this I'm giving. Okay. So like this I'm giving. It will print 10. So then current node is equal to current node dot previous, because this will become current node. It's a previous field. Like this I'm taking. It's a previous field like that. That's all. No other modifications are required. So try to print in the reverse direction. Let us call that function. So print list is there, right? I'm printing RL. So what is the last element available here? The last element which we have is a 10. So then we are going to get arrow mark like this, and then 5, then arrow mark like this, 3, like this we are going to get. Let me cross check, sir. Sir, is it coming in the reverse direction or? Yes. Since we have tail pointer, we can reverse the linked list. Of course, it is not reverse operation, sir. Just we are traversing from the ending to beginning. There is no disturbance in the list. This is nothing but what we have. Clear, friends?
Yes, sir. Clear, sir.
Yes, sir.
Then, sir, one more small concept. Please listen. With that, display function is going to be completed. See here. Sir, every time we are calling print list function, can't we print directly list? No. If you print list, what will happen? You can see. Sir, we are
Address.
getting the address of that particular list, the total list address. Sir, I don't want this. I want the content when you are printing directly. Sir, what we have to do? You need to write one more method similar to this print function. What is that method is? Sir, do you know there is one special method is there called underscore underscore str. So overriding of this method we have to take. So df underscore underscore str underscore underscore within bracket cell. If you write any code here, it will print that code. Sir, what I am going to do is I will declare one empty string, because it will return always string. My current node will become, okay, my current node will become always self.head. Then while your current node is not equal to none, if your current node is not equal to none, then I'm going to check, I'm going to add string is equal to string plus, in the formatted string I am printing, your current node is there, right? It's a data and then arrow mark. So after this, what we are doing, your current node will become, so current node dot next. And at finally, what we are going to do, I will return the value of yes. That's all, sir. Now see what will happen. If you print the list, instead of printing this address, we are getting 3, 5, 10 like this. Sir, up to this came, but last I want to add none. So what we can able to do? Better at last we can add none, right? So how to add yes is equal to yes plus. Can I take none here? Yes. Now see what will happen. We are getting like this. So this is the way how to print. This is the way how to print the list format directly. In this case, we are not required to call print list function explicitly. Automatically, it is going to print. So with this, we covered print list display operation, overriding string representation I covered. So is these two concepts are clear for you people, sir?
Yes, sir. Clear, sir.
Yes, please confirm everyone. Is it clear?
Yes, sir.
Right. Sir, now can I write this print list function in a recursive manner? Yes, we have an option, right? So print nodes. So print nodes using recursion. I will change the function name as a print list r. I will pass self and then some node. Let it be temp. Let it be temp. Sir, how to print this particular content? First, we are going to check. So if your temp is equal to none, simply I'm going to return. Which value we have to return, sir? None we are going to return. None we are going to return. If it is not the case, then what we are going to do? So we will print, so temp dot data. We will print the temp dot data and end is equal to some arrow mark, something like this. And I'm going to transfer the control to same print list recursive by passing so temp dot next. That's all. Now see what will happen. We are calling the function to the next node. Sir, I am taking print list in the recursive style. Let us see what will happen. Let us see what will happen. Sir, is the content is printing? Sir, print list is missing one required positional argument. Here we have to pass which one? We need to pass the first node, which is nothing but, can I say list dot self dot head? Yes, because we have to pass the head pointer, no pointer called self. So
Sir,
better to take
outside we
self.
cannot go self.
Yeah,
We can use
Recursively,
object reference. We can use a list.
yeah. List dot head I'm taking. Print list R is not defined.
sir,
It is
open recursive function, sir, once.
Sir, while calling use self now.
no object reference we use it, right?
No, in the function while calling you need to use self. Because that function is also
Right. One
while
second.
calling
Here
you
is
need to
the
use self.
here we have to take self dot. So you can see the data is coming, but here some new line characters problem. Of course, I want to print none also. So what I am going to do is when temp is equal to none, I will print the none and then I am going to return the control. Now see what will happen. Yes, perfectly using recursion, using str, that is overriding of that function, and using recursion. All the three possible display functions I covered. Can you please confirm, is the concepts are clear for you people, friends?
Yes, sir. Sir,
Yes,
one
sir.
more thing. If we want to print it in reverse, just we can use print statement after calling the function.
Yes, that's all. Automatically it is going to do in the reverse.
Okay,
Sir,
sir.
in str underscore of str also colon minus one is used, sir.
No, that is not
Overriding
required.
method.
No. That is not possible because we are giving the string in a different format. So string, if you take reverse, the elements won't be reversed. See, if you are giving 501, then 105 will come. That is not our requirement. Elements we have to reverse. Okay. Right. Sir,
Sir, why
please
is in
confirm.
self dot print? Why self dot? Sir?
Because we are inside the class, we are calling these things. That's why always you have to call the methods by using self.
Yes.
So outside of the class we have to use object, but inside the class we have to use a self reference variable. Sir, I request everyone to please confirm, is the concept is clear up to this?
Yes, sir.
Please
Clear.
confirm. Please confirm everyone, is it clear?
Yes, sir.
Yes, sir.
Right. So this display function, print list display function, insert function is also completed. Now my requirement is we have to write code to insert the object at the ending. Sir, we will see how to write code for insert at last. So insert at last. So def insert at last I am taking, where we have to pass self and then data. Sir, how to insert at last? The first step is we have to create a new node is equal to, so self dot node of, we are going to create a node with the given data. Next field is none, previous field is none, and immediately one node got created. Self dot count will become self dot count plus 1. Okay, suppose if your self dot head is equal to none, that means if there is no nodes, then self dot head will become the newly created node, and self dot tail will become the newly created node, and then we have to return the control. Sir, that is not the case. Already we have some nodes are there. Suppose consider I have some nodes are there like so 10, okay, and I have another node is there called 20. Okay, next I have another node is there called 30. Like this, we have three nodes are there. Already these three nodes are created. Now this node is pointed out by head. So next node is this one. For this previous node is this one. For this previous is none. For this next node is this one. Previous node is this one. For this next node is none. So this reference is also there with us. What is the name of this reference? Tail. Like this we have. I want to create a new node where we need to create insert at last. So this is nothing but your new node, right? Now I want to create 40 and the name of this node will become new node. So anyway, next field and previous fields are empty. Sir, now it is going to check. Is your self dot head is equal to none? No, because already, so my list is existed. Then what we have to do? Sir, very simple operation. Your new node is there, right? Its previous field will become tail. 1 second. Sir, new node dot previous field will become tail. So what is the link that new node dot previous field will become tail? Then after this, what we have to do? Sir, after this, I am taking self dot tail dot next will become self dot tail dot next will become new node. Sir, self is there, its tail is there, this one. Its next field will become which one? New node. Automatically link is created, right? Now tail will become change or not? Yes. So I am taking self dot tail will become newly created node and simply return the control. So where my set tail is going to point now? The last node, that is newly created node. And since these are local variables, it will be gone and its reference is reassigned. That's why it will be gone. This is nothing but a new node what I have. Sir, I think you people got very clear clarity about this. We are not required to traverse from the beginning to ending since we have another reference is there at the ending. That's why simply by using that reference, we attach the node. Sir, what is the advantage of this tail variable? I think you got clarity. Can you please confirm is the concept is clear up to this whatever I covered?
Sir, it
Yes,
is
sir.
clear, but I have a doubt. You are returning, or you are not returning anything, it will return none. Now we need to return head here.
No, if head is received, I mean, when you are calling the function, so outside of this class or anywhere, then there is a chance to return. But here, what we are going to do is, sir, we are updating the head and tail within the class only. This head and tail are instance values, right? That's
Yes.
why inside this class, whatever modifications that we are giving, that will be final. Suppose if you are doing this insert last function outside of this particular class, then what will happen? So that will become a function, not a method. So there, whatever operations that we are going to do, so it will take a list and it will do operations. That new list reference you have to reassign. Then only that value will be affected. Got it?
Got it. Clear, sir.
Right. So actually here return keyword is not required, but for my convenient purpose, but here return is required because once if this condition is satisfied, after completing these two instructions, you need to come out. Otherwise, what will happen? This part also is going to execute. I'm using this functional programming concept effectively. Other than that, nothing. Got it?
Yes, sir. Clear, sir.
Right. So let me check, sir. Already I have this list. So I'm not using this print list function directly. I will use. If you want to try to call print list dot size. So first step is what? If you run this code initially, the list will become empty, right? There is no elements. So now list dot insert at last I am taking. I am inserting 10. We have only one node is there. So that node will be created. No attribute at insert at last. What happened? So now you can see, sir, is the object got inserted or not? Yes. Now I want to insert a few more objects like 20, so 30, and then I want to insert 40. So total tail is not defined somewhere.
Self dot tail, sir. Previous connection is equal to self dot tail.
Good. Now you can see, sir, totally we have how many nodes are there? 4 nodes are there, 10, 20, 30, and then 40. This is the way how we can work with the double linked list. So hope you people understood this concept. Please confirm any doubts up to this.
No, sir. Clear, sir.
Right. Next. So with this insert at last got completed. Now we have to see insert at a specific location. Sir, I want to insert the data at a specific location. Okay, consider this program as it is available. Sir, I want to insert some data at the location, sir, given location. So insert at location. Sir, how to do this? So insert at location I am taking, where I will pass a self value and index value where we need to insert, and then data. Sir, multiple cases will be there here. Please listen carefully. Suppose if your index value is less than 0, or if your index value whatever you have given is greater than self dot size or self dot count, anything you can use, then what will happen? So we are unable to add the thing out of range. Out of range we are going to print, and immediately we will return the control. Sir, my index is in the proper location only. Then we are going to check whether the index whatever you have given is 0. If your index is 0, then what is the meaning? So is it at insert at first or not? Yes. Then I'm going to take, so self dot head dot previous, self dot head dot previous is equal to, sir, can I take a new node? Yes. Then, so means what? Sir, it will be added at the beginning. Then, so self dot head, its previous field will become this new node. So after this, what we have to do? Your new node is there, right? Its next field will become, can I take self dot head? Your new node will become self dot head. So that means its next field I am attaching to the new node. Sir, after that, so self dot head will become new node. Then return the control. So now this will become your head node. This will become your head node. So this happens when if location is equal to 0, sir. Sir, now listen carefully. If I want to do this operation, compulsory you should have new node. New node is equal to, sir, I'm going to create self dot node with given data. Next field is none, previous field is none. So after this, so self dot count will become, okay, already available count plus 1. We have to increase the count. This is the way when index is equal to 0. Sir, my index value is equal to, so self dot count minus 1. Means what? In this example, if I am in